Hi everyone, my name is Nathan Tabor and I'm a Senior Product Manager here on the Amazon Kubernetes team at AWS. And today we're going to talk about building modern applications with Amazon EKS. So let's go ahead and get started. We're going to cover the basics of Kubernetes and how AWS helps you to build modern applications. We're going to talk about how Kubernetes helps with operational acceleration, how AWS is using Kubernetes to give power to developers, how we're powering your platform with Kubernetes, and the road ahead for EKS and Kubernetes on AWS. All right, so what are modern apps and why should we even bother with them? Modernizing is arguably a lot of work, and it's not really obvious that it's worth our time and money to go and refactor all the stuff that we've built and actually build modern applications, changing our code, changing our processes, changing how we use our teams to do this. So why do we even need modern apps at all? Well, modern apps reflect our changing world, that businesses today are increasingly digital, and that the rapid delivery of software products is essential to a healthy business, regardless of industry. And this wasn't always true. While some businesses have used digital systems for a long time, it used to be that these businesses that really benefited from software systems and digital systems were mainly technology companies. And now businesses, nonprofits, educational and governmental organizations, their fortunes are more tied to the rapid delivery of software products than ever before. And they have to grow and evolve in order to serve their customers and their constituents. And these organizations are facing massive pressure to evolve. And there's really two paths as you think about it. Like, if we're moving towards software and we're moving towards delivering software faster, you have, two ways to do things. You can have a really great team that's really, really excellent at shipping software. And, a lot of legacy teams look like this. They are experts in their field and they know exactly what they're doing. They're doing things like handcrafting deploys. And what leads to these things when you have really great teams and really smart people, but not necessarily great practices, is things start to go slower and slower. Your releases get bigger. You do things manually. You have a small set of people that knows how to do things really well, but the larger team defaults to them. That means that this small group of superstars isn't willing to change anything. There's too much risk involved. You have these zero failure policies. You require executive sign-off. You end up with long planning cycles. And what starts out looking really, really great is a spiral to slowness. Instead, if you look at, how do we deliver software faster, and you focus on velocity, which is, continuous delivery, doing automated testings, getting things that are componentized and reducing the size, increasing automation, releasing quickly. These don't rely on people. They rely on processes, and you get this velocity flywheel. And so it's this evolution of processes that helps us build in a modern fashion. And this is one of the biggest things that organizations are looking to change as they move towards modern apps. Modernization also means an evolution of approaches. It's going from people to robots. It's going from manual processes and large databases like package managers to using immutable images, basically going from any sort of a database to code-based configuration, bringing siloed teams together with integrated tooling, and really focusing, instead of the productivity of small groups, instead of the velocity of the entire organization. Overall, it's about increasing automation, increasing componentization, increasing configurability, bringing teams together, and focusing on delivering small things more rapidly rather than a big thing in a perfect way. And so effective strategies for modernization look like focusing on modern operations as the checkpoint to velocity over development improvements, using things like container orchestration to realize CI and CD, and incrementally involving the entire organization, not just having small teams of experts building new projects. It's really treating the operations and treating the way that you build things as one of the most important things as what you're actually building. It's not actually just changing your code, it's changing everything about how an organization works. And all of this is very strategic. It's all kind of fluffy, right? And it comes together into what we call the AWS best practices for building modern applications. And really the theme across all of this is automation. Everything in this list allows DevOps teams to automate delivery of code to production, making it easier to ship code that is smaller and faster to repeat without errors, getting rid of the planning barriers like capacity and security, and the end goal here is to reduce the number of any manual steps, to reduce the presence of anything manual in the entire process of developing and deploying things out to your customers. So, this is a very abstract discussion, right? We're saying customers want to go faster. Customers need to bring, software delivery into the heart of your businesses. Why does any of this matter? What's the payoff here? And the reality is that we see that teams that practice continuous delivery and practice these velocity practices, they ship more code faster and with more confidence. And they're effectively, these pipelines are here to stay. They're the new factory floor. And they're the place where we build things, the place where we understand and secure our data. It's an entire practice that involves how we do software and how we also manage our teams and how we organize ourselves as companies. And so at AWS, all of these principles are really important to us. And these are principles that we see as really important for our customers as well to help them move faster and to be successful in their businesses. And so how does this all tie into Kubernetes? Because these are all great practices and they all look really, really great on slides, but how do we actually bring these back and how do we actually make these a part of the practice that we have for shipping our code? Well, Kubernetes is a critical enabler of these strategies. So much of Kubernetes supports the idea of shipping small things quickly, the ideas of immutability and continuous delivery. We actually see Kubernetes at AWS not as just a platform for developers, but as a platform for operations acceleration. And this is because the properties of Kubernetes make it so that it's very easy to implement all the best practices in terms of how you accelerate your software delivery. And this is because at the core of Kubernetes is the concept of convergence. It's the idea that your entire state of a system is declarative. So you're going to declare a desired state. You'll measure that desired state against reality and compare, is this state that we have actually what's in existence? And if there needs to be a change, then that action will happen and will change to be closer to the desired state, and then that becomes the new desired state. And so we're in these convergence loops where we're constantly managing drift. And the entire system of Kubernetes is built around these convergence loops. All of the different components of a Kubernetes software is built around reconciling these convergence loops. And so that's actually awesome when you look at how Kubernetes operates inside. But for customers, there are new patterns like GitOps that actually extend this convergence cycle outside of the Kubernetes cluster. And this is something that we're increasingly seeing customers adopt, is using Git as the center of the cluster state and configuration that you declare via a CI pipeline, and then Git uses continuous deployment and that convergence loop to actually implement that declared state onto the cluster. It's a single source of truth of a system's desired state where all the intended operations are committed by pull request and everything is implemented with automatic convergence. It also means that we're not hiding things under the covers. So any changes that we're making across our systems are observable, they're verifiable, and they're auditable. And this is really important, especially as your organization scales and adopts new tools like Kubernetes, because what will happen is you'll end up with lots and lots and lots of clusters. You'll end up with lots of implementations of this software across your organization. And you need a way to not only have things be automated, but also have things to be auditable and observable and verifiable so that you know that one change is what resulted in this system state being different. And having the ability to go back if something does go wrong and actually trace that change all the way back to where it actually originated so that you can troubleshoot it or you can remediate it. So let's actually give this system looks a little bit complicated to set up, right? Like this, we've moved very quickly here, and there's a lot of things going on. We have a Kubernetes cluster, we have a CI pipeline, we have our IDE. We're taking this stuff and we're implementing on a cluster. But I want to show you just how easy we're making this at AWS to implement. So we have a tool called EKS Cuddle, and today we just have some slides, so I don't actually have a live demo of this, but we can talk through how this actually looks, which is EKS Cuddle is a command line tool for EKS, and it automates creating a cluster and actually setting up a GitOps pipeline with that cluster to do declarative configuration via Git. So we have two commands. The first is EKS Cuddle create cluster. This actually creates a complete EKS cluster in your environment. And then we have EKS Cuddle enable repo. And what this does is it actually connects this Git repo that you declare here directly to your cluster. And so the system looks like this. You have your Git repo, and within the Git repo, you can declare any of the deployments or services or whatever YAML or even Helm charts that you want to apply. And there's an operator that goes on your cluster called Flux. And Flux is the GitOps operator. And what this operator does is it looks at the state of the Git repo, and it's running that convergence loop for you, right? So this is a bit of code that's looking at your Git repo, and it's constantly seeking to converge the state of that Git repo with the state of the cluster. And so when a new manifest is committed and pushed to the repo, Flux looks at that. It sees that there's a change in the declared state, and then it goes and deploys that on the cluster so that the desired state meets the declared state. And this is just one of the ways that we're seeing customers use tooling like this to accelerate their operational processes and really drive acceleration in how they actually manage things across lots and lots of software. So we think it's incredibly important. So let's go ahead and actually move on a little bit and talk about some of the tooling that AWS has been working on to enable developers with Kubernetes. So AppMesh is a managed service mesh for Kubernetes and all of AWS that makes it easy to monitor and control microservices across AWS and not just within a single cluster. So we launched AppMesh so that you have managed infrastructure that we provide for you and that you can deal with network conditions as a developer. And AppMesh lets you manage all of the networking configuration for your different services without having to implement the networking rules and policies directly in the code. So as a developer, it lets you actually abstract away from coding these things in, having service A talk to service B, and instead to manage it outside of the service, outside of the cluster, in a standardized and consistent way. And what's fantastic about AppMesh is that we recently just shipped a controller that lets you manage all of AppMesh directly from a Kubernetes cluster. And so the way that this works is that AppMesh connects your Kubernetes pods and services directly, acting as a proxy. And this simplifies the work that you need to do as a developer to implement service networking and to connect your application. Another piece of innovation that we've been working on at AWS and that we've recently announced is the Cloud Development Kit for Kubernetes, or CDKs. The Cloud Development Kit for Kubernetes makes it easy to go ahead and actually implement everything for your Kubernetes cluster, to define your Kubernetes cluster using common programming languages. So using the CDK for Kubernetes, you can define all of your applications and architectures using familiar programming languages, generate well-formatted YAML for all of your applications. And what's excellent about this is that traditionally in Kubernetes, you have these very large data YAML formats. So if you need to define a bunch of services, you'll end up with a number of YAML manifests. And to distribute those across your organization, you need to send them to someone or have them in a shared repo. You need to copy and paste them or turn them into Helm charts with only a few variables. But what if you want to implement patterns? What if you want to tell your development teams, hey, this is what a web service looks like? CDKs really helps with that because it lets you actually build on top of these things by declaring certain configurations of Kubernetes objects as code libraries. And so you can turn these, my definition, for example, for how a web service looks can be turned into a code library, and then it can be shared through a package manager across the organization. And if there's ever an update to what I think a web service is, I can actually make that update in the library, and I can redistribute it. and then that just gets updated inside of the base layer, inside of another developer's IDE. You pull that library in, and then the next time they generate YAML, that YAML is actually generated with the updates that I've pushed. And this is awesome because it allows you to actually move Kubernetes and give it to more people, and give more developers the opportunity to write Kubernetes without having to become experts in how to define and manage YAML. What's really cool about the CDK for Kubernetes is that it runs locally, so it lets you deploy to any cluster, and it actually just generates Kubernetes standard YAML. So it's nothing actually specific to AWS. It's specific to Kubernetes and really makes it easy to standardize across on-premises and the cloud. So today we support JavaScript, TypeScript, and Python in the CDK for Kubernetes. Tomorrow we're looking to support Go, .NET, and many more languages. I talked a little bit about how it allows you to share best practices as libraries. So you can compose and share reusable components through code libraries. This really helps organizations standardize how they define Kubernetes and is an important part of that operational acceleration. And then finally, one of the most amazing things that we've seen with the CDK for Kubernetes is that it really aligns nicely with the GitOps methodology that we were just talking about. So traditionally, developers are working mainly with their code, and then they're working with a deployment pipeline. So you're writing in code, and then you're deploying that code through a pipeline. With Kubernetes, you're often writing that code, deploying it through a pipeline, and then your Kubernetes configuration, you're actually writing in the YAML data format, and you're deploying directly to a cluster. But by using CDKs together with GitOps, you can actually have a parallel and symmetrical pipeline for how you configure your cluster as how you actually you write and deploy your code. So just like with your code, you can write the configuration in a common programming language, and then you can use the GitOps CI/CD pipeline to deploy that out to the cluster. And so instead of having two separate workflows, you can have the same parallel workflows for both defining your code and your application and defining the configuration of that application, how it runs on the Kubernetes cluster. All right, so let's talk a little bit about platform. Kubernetes is ultimately a software platform. And this means that at the end of the day, Kubernetes is only as good as the environment where it's running. So things like uptime and reliability and availability, they all translate to your application quality, and this translates to your users. And this means that if the environment you're using actually doesn't have good uptime, doesn't have good reliability, then it's going to be exceedingly hard for you to provide a good quality of service. There are ways to work around it, but it starts to take a lot of time and it starts to take a lot of effort. And so we believe that by choosing the best quality platform and the best quality environment to run your Kubernetes, that allows you to have the best implementation of your applications. That's the best way to make your users really, really happy. And so our mission at AWS is to make AWS the best place to run Kubernetes. And part of that is up to the work that we do in Kubernetes and the services that we provide around Kubernetes. But a good amount of that is also due to the quality of the environment and the reliability and the uptime and the service level agreements that we had for all the core foundational services, things like EC2 and VPC, that provide the core compute, networking, and storage that are needed to run a highly available and reliable Kubernetes platform. Another way that we do provide Kubernetes at AWS is with Amazon EKS. EKS is a fully managed Kubernetes service that provides the Kubernetes control plane and worker nodes as managed nodes within the AWS APIs. EKS is 100% upstream Kubernetes. We offer a highly available control plane that automatically spans across availability zones and allows you to run a highly available regional Kubernetes service. There's lots of integrations that we built with the AWS platform, for things like VPC, for IAM security, auto-scaling, and things for storage and networking, and everything that you need to run a really, really good Kubernetes platform is given to you with Amazon EKS. And there's a few guiding principles for how we do this. The goals for Amazon EKS is that this is a production-ready platform. So when you get an EKS cluster, it's ready to go in production that moment. It's highly available, it's highly scalable, and it can run production workloads from the moment that you start it up. but it's also very important for us to run native in upstream. And so we run the latest versions of upstream Kubernetes, and we bring that in regularly to our platform. We validate that, make sure that it's working, make sure that all security fixes are applied, and we make that available to customers. Open source contribution is also incredibly important to us. So being part of the Kubernetes community, and at AWS, we have people sitting on multiple Kubernetes SIGs, people that are lead contributors for things like etcd, and we have a number of open source projects. One of them that we just looked at a minute ago, the CDK for Kubernetes, that are actually built around making Kubernetes better for both people on AWS and everywhere. And then finally, seamless integrations to the AWS platform are essential. So we talked a little bit about the different integrations that we have, but things like the IAM Authenticator and the CSI drivers and the CNI plugin for VPC networking, these are the integrations that when you come to run Kubernetes on AWS, everything should just work. And our vision is really that you can have everything you need to build and run your Kubernetes applications in a single place. That you can create a cluster with all the compute resources, tools, and control that you need to run your application. And we really believe in building smart automation for Kubernetes that lets you take advantage of the building blocks that you need without the ones that you don't to build powerful applications. And we'll always bias towards giving customers tools that they need with the right level of automation that helps them build faster. And that's really the goal of the Kubernetes team at AWS, is to allow you to come in and to get what you need and to run it really, really quickly. So let's talk a little bit about a few important things to note for EKS. The first thing is that we have global availability. So we're available in over 20 regions around the world right now. So anywhere that you're looking to run your applications, we have Kubernetes available for you. We also have a very high service level agreement of 99.95%. And this is for the actual hosted Kubernetes cluster. That we guarantee that this cluster is up 99.95% of the time, or we have a service credit that we give to customers in the case that we don't meet this agreement. But this is the agreement that we have, and we really stand by this and are able to achieve it. Because of the way that we operate Kubernetes, because of the way that we validate Kubernetes, and the way that we operate the cloud and our services. And we've had a number of customers with a lot of success running Kubernetes and Amazon EKS on AWS. Customers all the way from Amazon.com that uses EKS to power the homepage, to Babylon Health that uses EKS for an artificial intelligence platform, Personal Capital that has really seen a large amount of acceleration using Amazon EKS, Bird Mobility, which is a scooter sharing company. They built their modern stack on top of EKS, and to Square that built Cash App, which is part of the Square cash sharing ecosystem on top of EKS. And these are companies that are able to come in, build on EKS, quickly scale to millions or more of active users, very, very high application growth, and able to have a really high level of service with Amazon EKS. One of the most successful customers that we talk about a lot is Snap. Snap has actually migrated to 100% Kubernetes on the cloud, and they moved a good amount of their core messaging architecture to AWS and EKS, breaking from a monolithic application into service-oriented architectures and microservices, and been able to effectively cut down the amount of time that it took for their teams to deploy applications from weeks to days, and to really be able to grow the business and accelerate while reducing their overall costs significantly. And so these are just a few of our customers that really are epitomizing the vision that we see for EKS in the future. And the vision is that EKS is a globally available way for customers to run Kubernetes. It's easy to use, it's production ready, it's cost effective, and it's high performance. And these are all the things that we think it makes it really easy to build with Kubernetes on AWS. So there's obviously a lot to our roadmap. There's a lot of things that we're constantly working on. Instead of actually taking all this time to go through all those details and all the things, I really want to point you in the direction of checking out the AWS Container Services roadmap on GitHub. This is an excellent project that we maintain and we're regularly engaged in. You may even find me on there responding to comments or questions. And this is where we actually put the entire roadmap that we're working on for Amazon EKS and for other AWS container services on GitHub. And we also accept pull requests. We accept issues from the community. So if you have an idea of how you think that we can improve our container services or improve Kubernetes on AWS, we'd love to hear it. And you can go ahead and visit github.com/AWS/containers roadmap to see what we're looking to build and to leave us any suggestions. And then finally, if you're looking to build modern applications on AWS and to continue learning, we have live instructor-led courses that offer accredited AWS instructors who are going to teach a mix of presentations, discussions, and hands-on labs. These courses let you learn how to modernize your applications. Their courses are things like architecting on AWS, developing on AWS, and DevOps engineering on AWS. And there is a number of learning paths that you can take that are tailored specifically for your role. Awesome. Well, I know this was a short presentation giving you a taste of the things that we're doing at AWS to help enable modern applications. I really appreciate your time. Thank you so much. And it's been great to have you. Thank you.